So the next construct is a for loop. So this is probably the most common type of loop operator that you're going to use in R. The basic idea is that you have a loop index, which is typically called I, but if you have many loops, you might say J, K, L, etc. And a loop index is going to cover a sequence of numbers, typically integers. So for example, here I've got a for loop, and it's looping over the numbers 1 through 10. So I've created the sequence with the colon operator, 1 through 10. And this for loop is not doing anything particularly interesting. It's just printing out the number. So I'm printing out I at each iteration. After the loop is finished, it continues on to the next block of code. So there's different ways to use a for loop, and R is pretty flexible about how you can kind of index the different types of R objects. So here I've created a vector, a character vector, with the letters A, B, C, D in it, and all of these for loops are equivalent. So for example, in the first one, I kind of done what you might commonly see in other languages like C that have for looping. Here I've got an index I that I sequence through 1 through 4. I create an integer sequence, and then I print out the ith element of X each time. So here this loop just prints out A, B, C, D. Another thing I can do is use the seek along function. So seek underscore along. What it does is it takes a vector as an input, and it creates an integer sequence that's equal to the length of that vector. So this is a vector of length 4, so it's going to create an integer sequence of 1 through 4. It's exactly the same as the previous statement where I've got the sequence 1 colon 4. However, here I generate the sequence based on the length of the variable x. So now my index variable I is going through this sequence. It's printing out the ith element of x, and exactly the same behavior occurs. I print out A, B, C, and D. The third example here, I've got a different index variable. I'm calling it letter, and the index variable is actually going to be taking values from the vector itself. So there's no reason why the index variable has to be an integer. It can take elements from any arbitrary vector. So now the for loop is going through this vector of letters A, B, C, D, and it's just going to print out the letter itself. So now I'm printing out the index variable, which happens to be equal to the letters in the vector. And so these three for loops are exactly the same so far. The last version here is the same as the first one, except that I haven't included the curly braces. And so for a single expression, if the for loop only has a single expression in its body, you can omit the curly braces and put everything on one line, which may be useful sometimes because it's a little bit more compact. But it's not my particular style. For for loops, I generally like to put the curly braces in, regardless of how many elements are in the body. For loops can be nested, so you can have a for loop inside of a for loop. So the common thing, for example, is with a matrix that has 2 dimensions, and then you might want to loop over the rows and then loop over the columns. So here, the outer loop, the I with the I index is looping over the rows, and I'm using a function that's called seek underscore len. So the idea is that it takes seek underscore len takes an integer, which in this case happens to be the number of rows in X, and then it creates an integer sequence out of that. So this particular matrix has 2 rows, and so it's going to create the sequence 1 to 2. For example, similarly, the nested loop with the J index is using the number of columns to create a sequence. So this matrix has 3 columns, and so the seek underscore len function is going to create an integer sequence 1 through 3. So this doubly nested for loop is basically printing out all the elements of the matrix. So one thing to be careful with nested for loops is that it's going beyond 2 to 3 levels. While it's theoretically okay in R, it makes reading the code a little bit difficult to do. And so if you're reading code that has 3 or 4 nested for loops, it gets difficult to understand what's going on. Sometimes that's a logical thing to do, but many a times there's ways to get around that, for example, by using functions.